Okay, I know you're probably getting sick of these, but these are some more sum and difference problems. Notice you see the word identities on there. I'm sorry, but we're kind of combining sum and differences and identities. But these are not as bad. They follow more of a similar pattern on all of these, okay? So if we do this first problem, notice it says that you have to prove this. Again, I'm giving you a statement that I know is true, and you can be guaranteed is true, and you just have to prove to me that it is true, okay? Again, when you see on the left side, is going to make you think that you can just distribute, sorry, but you can't, okay? You must use the sum and difference formulas. So this is like your alpha right here, and this is like your beta, and you're going to follow the formula for the sign at alpha minus beta, which of course is right here. I know this is a little bit small, but you do have it on your notes. So I'm going to follow the formula for sign at alpha minus beta. In place of alpha, I'm going to put pi, and in place of beta, I'm going to put theta. So I'm following the formula that's circled, and I'm going to put sine at pi, cosine at theta, minus cosine at pi, sine at theta. Okay? From this point, you need to use your unit circle. So if you don't have those out, you might want to. You're going to go to your unit circle, and you're going to need to find sine at pi. So if you use your unit circle to remind you, pi is over here. Your sine value, of course, is your y value. And at pi, that means my y value is 0. So I'm going to take 0 times cosine at theta. And then I need to find cosine at pi. And of course, cosine at pi is your x value. Okay, so same spot here. Cosine is your x value, which is -1 at that spot. So cosine at pi, this whole thing, gets replaced with -1. All right, and over here, and I'm going to just put this in parentheses, 0 times cosine, 0 times anything is 0. So I have 0 minus, and then -1 times sine is negative sine. And then obviously when you subtract a negative, you're going to be able to add, and you're going to get sine. Okay, so that's how that one works. Pretty simple. Okay, moving on to a tangent one. There's a couple different ways you're going to attempt tangent ones. I'll show you this one first, which is kind of the traditional way, very similar to what we did the last one, and then I'll show you something else that happens sometimes with tangents. So again, this is like your alpha, this is like your beta, and you're going to follow the formula for tangent at alpha plus beta, which of course is right here. Okay, so tangent at alpha plus beta will look like this. Instead of alpha, I'm going to write pi, and instead of beta, I'm going to write theta. So that's what it will look like. Then I need to go to my unit circle because I can replace this quantity with a number, and I can replace this quantity with a number from my unit circle. So again, I'm going to go to my unit circle. Pi is over here. Tangent is your y value over your x value. And so when you do your y value is 0, your x value is -1, so 0 over -1 is 0. Okay, so tangent at pi is 0, which works out nicely. So I will have 0 plus tangent at pi over 1 minus 0 times tangent at theta. Oops, not tangent at pi up there, sorry. Tangent at theta. Okay? Well, again, 0 times anything is 0, so that quantity can drop. 0 plus tangent at theta will simply be tangent at theta, so I don't need this 0 right here. And so I'll have tangent at theta over 1, which of course is just simply tangent at theta. So that's one way to do tangent problems. Sometimes, though, this will happen, and I'll show you. Okay? Similar problem. This is alpha, this is beta. Okay? So you're going to follow the formula for tangent at alpha minus beta right here, it seems like. And you'll go tangent at theta. Your alpha is theta, and your beta is pi over 2 here, plus tangent at pi over 2 over 1 minus tangent at theta, tangent at pi over 2. Okay, so now again, I need to be able to replace tangent at pi over 2, that quantity, with a number from my unit circle. So I go to my unit circle, and I go to pi over 2, which of course is up here. Tangent is y over x. And what I notice is this. My y value is 1, my x value is 0, and you can't divide by 0, and so tangent at that spot is undefined. It's not 0. I can't plug in the number 0 there. It's undefined. And when something is undefined, that means it doesn't exist. So I can't plug anything in there. There's nothing to replace tangent at pi over 2 with in that red circled part. So this strategy actually did not work. It didn't work to follow that. But what I can do then is this. I know that instead of tangent, if I use my trig properties, tangent can be written as sine over cosine. Okay, sine over cosine, I don't want that there. So what I can do is I can write this as sine at theta plus pi over 2 over cosine at theta plus pi over 2. Okay? Now, kind of a pain because I have to do this twice, but I can handle it. So sine at theta plus pi over 2, I'm going to follow this formula. Sine at theta plus pi over 2 is like sine at alpha plus beta. Okay? My alpha will be theta, and pi over 2 will be my beta. So I'm going to follow that formula for the red part. So I will have sine at theta, cosine at pi over 2, plus cosine at theta, sine at pi over 2. And then on the bottom, cosine at theta plus pi over 2, I'm going to follow this formula right here. Okay? So cosine at theta, cosine at pi over 2, minus sine at theta, sine at pi over 2. Okay? So that's where I'm at there. Now, people get tempted to just cancel like this out. I don't know if you can see these little dots. This with this right here. But you can't do that because you can't separate those entities that are separated by addition and subtraction signs. So that is not going to work to do that. Okay? But you can go to your unit circle and replace some quantities. So I can figure out what cosine at pi over 2 is on my unit circle. And I can figure out what sine at pi over 2 is. I'm going to start with cosine. So I'm going to go over here. At pi over 2, I already have circled in red. My cosine value is 0. Okay, so I'm going to go back here and realize that cosine at pi over 2 is 0. So now I have this. I have sine at theta. Cosine at pi over 2 will be 0. Plus cosine at theta. And now I'm going to find sine at pi over 2. Okay, here's pi over 2 again. My sine value is my y value, which is 1. So sine at pi over 2 will be 1. So I can replace this quantity right here with 1. Same thing on the bottom. Cosine at pi over 2 is 0. I already calculated that. And then I have minus sine theta. And sine at pi over 2 I already calculated as 1. All right, so here's the good thing. 0 times sine is going to be 0. 0 times anything is 0. And 0 times cosine, 0 times that is still going to be 0. So on the top, I have cosine times 1, which of course is cosine. And on the bottom, I have negative sine times 1, which of course is negative sine. And then, if you remember your trig proportions, cosine over sine is the same as cotangent. So this will be negative cotangent at theta, which is what I needed it to be from the beginning. All right, and one last one that we need to talk about here. This is one that looks kind of a little bit different, but this is what I have to do. Okay, I have a formula, or this is asking me to prove that cotangent and alpha plus beta is the same as cotangent alpha, cotangent beta minus 1, blah, 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 blah. Okay, the problem is this. I don't have a formula, a sum and difference formula for cotangent at alpha plus beta. I do not have a sum and difference formula for that. So I need to do something different. So what I can do is I can say that cotangent is cosine over sine. Okay. So what I'm going to do is I am going to do this. Cotangent at alpha plus beta is the same as cosine at alpha plus beta over sine at alpha plus beta. Okay, now I'm going to leave a big long space in here just so you know, so you can kind of know. I want you to leave room to write something here. So follow kind of my lead here. Cosine at alpha plus beta will be this formula right here. Okay, so cosine at alpha plus beta will be cosine at alpha, cosine at beta, minus sine at alpha, sine at beta. Okay, big space in between. And then I'm going to write this formula out, sine at alpha plus beta. So sine at alpha plus beta, if you scroll up, will be right here, which of course goes sine at alpha, cosine at beta, plus cosine at alpha, sine at beta. Okay, now if we look at where we are and where we need to be, here's the problem. I'm looking in the upper left-hand corner, and I am seeing that this says cosine alpha, cosine beta. This says cotangent alpha, cotangent beta. Okay? When I look in the upper right corner, this says sine alpha, sine beta. This says 1. Okay? One of the strategies you can do, which I'll tell you which ones to do in your homework, is to divide everything through by something. Sometimes the hard part is to figure out what to divide through by. But this is what I know. I know that sine at alpha, sine at beta has to turn into 1. Okay? So think about, what would you divide sine at alpha, sine at beta by to turn it into 1? Well, you'd have to divide it by itself. So sine alpha, sine beta. If you divide that quantity by sine alpha, sine beta, you have to divide every quantity by sine alpha, sine beta in the whole entire problem. Okay, so this is what happens then. Cosine alpha, cosine over sine beta, or cosine alpha over sine alpha becomes cotangent at alpha. Cosine beta over sine beta becomes cotangent at beta. Minus, these all cross out to make 1. And then down here, the signs cross out. And right here, you're going to get cotangent at beta, because cosine over sine is cotangent. Over here, the alphas cross out. And, oops, sorry, I just crossed off the wrong thing. Let me undo that for you. All right, sorry, the signs cross out. And you have cosine alpha over sine alpha, which of course is cotangent alpha. Okay? And that is exactly what we needed it to be, so we did it. All right, here is your homework, you guys. These ones that are highlighted in purple will be very similar to that last example that I just did, where you're going to need to divide through by something. So I'm giving you that hint from the beginning. The rest of them should be pretty straightforward, and I will help you when we get to class.